maybe, maybe not. We changed the setup, and now I don't know if the stream will work. Disaster. If I switch to this one. Oh, wait, no, I see something popped up on my phone. Does it work? Dismiss. All right, we got this nice full screen video. Look at this. We got production quality. Is there lag on this? If I move my hand, does it wave? Doesn't really matter because we're going to go to desktop. Oh, it looks like it works. Wow, look at this studio quality video. Really, we're just using whatever's baked into Mac OS. And I moved where I'm sitting, so that's really... We got big upgrades in these office hours for our production quality. Oh boy, we're like probably picking up my phone speaking. All right, cool. Let's see, does the Twitch chat work? Is there people in Twitch chat? Is this in fact working beyond just for me? New setup. This is actually the old setup technically. We got a few changes though. This is the OG setup of where I'm sitting. The changes are we've got fancy Mac OS stage lighting stuff happening. And I got glasses. I decided I should start caring about my vision. I did not have contacts before, in case you're wondering. We've decided that blindness is no more. Okay. Cool. Cool. Yeah, the pwn.college lecture background. We're back in the OG place. Basically, where I'm sitting right now is a little desk thing, and I used to always be sitting at that chair, the far back chair of that table. I sat there for all of the office hours up until here. And now we're back here because I decided and I've learned that I can plug my laptop into this big monitor that's here, and I don't have to deal with Linux, but I can have a big monitor. So we're going to see how that works. Hopefully it works nicely. If at any point text is very small or I'm blocking things, hopefully I don't mess that up, please yell in the chat. Yeah. Oh, we got someone that is a fan. Thank you from Morocco. What are we going to cover? Okay, we are going to cover, let's get into it. Let's quit messing around with our new production quality and let's get into content quality. All right, let's switch this over to this thing. All right, hopefully that worked correctly as I'm expecting it to have. If we come over here, I don't know, probably this text will be small. I don't know if I care. Let's see, I'm gonna double check a few times. Yeah, that's definitely gotta be real small. But probably you don't care about seeing Twitch chat. We are going to be covering web security. So we'll make sure that we zoom in here. Nice big website. We are going to be talking about web security, and we're going to be talking about whatever the heck you guys want to talk about with regards to web security. So start putting some questions in the chat if, you know, as part of these levels, some concept does not make sense. Ideally, that's in the form of a content-based question in terms of like, hey, what the heck is going on with same origin policy, or what the heck, how do I use JavaScript to like make a web request or something, right? Like in this class, you don't learn JavaScript, but I'm like kind of like, you know what, go figure out JavaScript. So hopefully you're able to do that. We can demo that a little bit though. Obviously, you might be struggling a little bit with JavaScript. Yeah, but you know what? That's kind of how life is. I'd hate to use the common excuse that I feel like instructors use, which is like, you know what, you got to learn on your own. But isn't that just the reality of the world? You know, you got to do some amount of learning on your own. Fortunately for you, in this class, JavaScript is one of those things. Just like Python was one of those things. You don't need to do too much fancy stuff with JavaScript or Python, you know. Probably you're going to be looking up some example on the internet of how to fetch a request. And then you just kind of copy and paste and modify a little bit, right? Like that's totally acceptable. As long as you're not like stealing solutions from each other. I don't know. Hopefully you know how the academic integrity policy works at this point in the class. Okay, let's go ahead and if I go here and we launch up this thing. Oh boy. Isn't that just wonderful? No, okay, good. And we will zoom in. Well, this isn't going to work, is it? We got to close that. I think I got to start a challenge. Let's just start level 1. Probably not going to be working with level 1, but we'll start level 1. That started up. Let's do this thing. Hopefully that gives me my VS Code. Hello, VS Code, where are you? There we go. Cool. Okay. That. Don't save. Discard. Close that. We might need that. We might decide we like that. Close that. Good enough. Okay, gotta remember top right is my face. Let's look at this. I feel like it's a little laggy. Am I dropping frames? I hope I'm not dropping frames. Dropped frames 0. Okay, no. CPU is only 9%. All right, we're gonna say we're probably good to go then. It says dropped frames 0, but then it says 21 out of 30 FPS. What the heck does that mean? We're dropping frames or not? Mixed signals. Okay. Does anyone have any questions then related to web security? Maybe as I'm waiting, since I talked about JavaScript, I'm probably subconsciously assuming you're going to struggle a little bit with some JavaScript. Maybe we'll talk about JavaScript first. As we await some questions to discuss these concepts. So let's go ahead and let's start simple. So if we go into live, ps1 equals that. Let's go to web security. And let's go ahead and create, test.html. That doesn't look right. Touch test.html, code server test. Maybe that is right. Okay, whatever. Oh, cool. All right, let's create HTML, right? So if we do very simple HTML page, we got a body, doesn't really matter. We're not really doing HTML, we're really just trying to do some JavaScript here. And I say, hello world, right? We'll keep very simple to start off with. And if I jump now into, let's say, the desktop, feel free to ask very basic questions. It is sort of laggy, not the worst. Well, keep me up to date on that. That becomes an annoying thing. If it does become annoying, please someone say that the lagginess is bad, and I'll investigate for a brief moment to make sure it's not bad. I wonder if I need to downsample more. That might require a stream restart if I do. Okay, we're gonna hope it's not too bad, but please, as I said, yell if it is bad. We're going to open up terminal. We'll say cd live, cd web security, web security, and Firefox test.html. Okay, so we've got our nice little web application. Hardly a web application, it's just a static page that says hello world. We can add a script. So I feel like the classic thing people do to make sure that JavaScript is working is they just do alert 1. It's just like the classic thing. If you do alert 1, it should see a little pop-up. And we see a little pop-up, it says 1. If you're curious how that works, you could say like alert, this is something I want to say. Right, and then we refresh. Oops, that's refreshing the website instead of that. Okay, refresh. This is something I want to say. Okay, very basic JavaScript. The screen is not updating at all now. All right, well that's terrifying. Okay, my face is updating. I see the screen is definitely not updating at all. Wonderful. Maybe if I do this, test. Nope. I didn't anticipate that as a possible issue. Okay, that updated it, but is that like, okay, this is, I think I can see it. What's happening? New setups. This is why we don't do new setups. Disaster. Okay. Okay, I think it's working. Tell me again if it stops working. All right. So this is very basic JavaScript. JavaScript, obviously, we can have it do other things. So for example, if I say div ID equals thing, and I say, you know what, we'll move hello world into this div, and I update this. We go here, we refresh this page, blah, 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 right? Still hello world. And if instead of this, I do thing dot inner HTML equals some text. Okay, you'll see that JavaScript updated that to some text. And if I knew JavaScript, let's see here, how do I, wait a second, there's, let's see, JavaScript, might as well do it the way I would actually do it. JavaScript, wait 1 second. Set timeout, that's the name of it. Okay, so if we wanted that to wait 1 second before we did that, JavaScript has this idea. This syntax might appear weird to you because maybe you've never used a language that has syntax that looks like this before. This syntax is basically defining an anonymous function. So this right here that I'm highlighting is the first parameter to the set timeout function. So you've called a function before. This is the first parameter. You can kind of think of this if you've used something like a lambda before. This is kind of like the lambda syntax within JavaScript. It's just an anonymous function. So I could instead say like function do, right? And put this there and instead pass do. And what this would do is that after 1,000 milliseconds, right, 1 second, why is this function do what? Pretty sure that's correct. Not def, right? No, it's definitely function. See, I don't write a lot of JavaScript. Function do. Oh, do is a reserved word. Test. Okay, that makes sense. This, right? This is the same syntax. After 1,000 seconds, we're going to call this function. So JavaScript is a very asynchronous sort of language. You want to like have these like callbacks. A callback is really just like a function pointer. It's just passing around a function. This function will get called in 1,000 milliseconds. This is just not how you would normally write this though, because we don't really care about this named function test. We don't care about being able to refer to this thing as test. This is where you just like inline it. Because all I really want to do is after 1,000 seconds do this operation, right? I don't really care about a function name. So if I do this and I load up this page, we'll see that after 1 second, right? It's initially hello world, 1 second later, some text. Okay, so this is basic JavaScript. We're still changing page. It's like a little laggy, but looks like it's working still. Okay, so this is, a very simple thing. You might imagine, so maybe we do actually, I just said it, function modify, or we'll say count. We'll say var I equals 0. We'll say I plus equals 1. We'll say thing.inner HTML equals I. And then we can do set timeout, count 1,000. Hopefully you see where I'm going with this as just like a random little thing. We can do something that looks something like this, right? Every 1,000 seconds, or we could probably even just count it, right? We don't even need to wait 1,000 seconds. Depends on what we're trying to do. Every 1,000 seconds, this will go up by 1. And we can say, you know, I can think about how JavaScript syntax works. This is like an F string, I think. We have counted to this, right? And then if we come over here, we've counted to 1, 2, 3, right? Like you want web applications to be dynamic, right? So this is, you know, this is what JavaScript was born to do, is to be dynamic. Now, maybe slightly more interesting thing we might want to do as part of being dynamic is the ability to fetch data from some other website, right? Go and fetch data from somewhere. And in doing so, we can display something. So let's concretize that a little bit. So I think in the last office hours, we kind of had this cool little web app. Let's actually get rid of, or we're not going to get rid of it. We'll just make another server. We'll say code server app.py, and we'll take a little bit of Flask stuff. We'll say from Flask import Flask, and then we'll do app equals, I'm so used to Copilot completing something like that. I wonder if there's a way for us to get Copilot in the dojo. That would be sweet. Oh boy. Pressed something we didn't want to press. Okay. App.routes here, def index, return hello world. Actually, no. Return open test.html read, right? We'll just read in this test.html and we will return that whenever someone goes to the root of this web application. And then we'll do, we'll just do the debug stuff. So we'll say app this, that's what we're looking for. Flask run. So we'll do app.py flask run. What do we have at the bottom? You mean couldn't import our app? What happened? Oh, did we not save? There we go. Okay. So now we're running on port 5000. So we've made it so we're no longer using file as our protocol, right? We're using HTTP as our protocol instead, which makes a little more sense. Localhost 5000. Okay, so now we got the same thing, but now we've got a web app. So for example, we might decide that if you ever hit the date route, so we'll say date, and what we'll do is we'll return, you know what, subprocess check output date. We'll just return that. So we'll run the date command in Linux and return it. So if I hit this and I save, what's going on here? Why is it not in development? Is that how you do this? how do I get, I want debug. It says, there we go. I want it to auto reload. Subprocess not defined. You'll see that that's what debug does in Flask. It's kind of cool. It like gives you a stack trace. If you ever get an internal server error, it just gives you a stack trace. Import subprocess. Cool. Okay, look at this. Now, I hit refresh again. We are struggling hard with this new setup. Okay. And so every time we refresh this page, it gives us the date, right? It's just calling date on our Linux system and returning the output of it. So we might want to make it so that in test.html, we can fetch that date, right? Rather than, just doing this, maybe also every second we want to fetch the date. Why would you develop an application like that? Who the heck knows? But you might want to. So this is where the fetch API comes in. Fetch API JavaScript. Let's see here. Then the fetch API allows you to start making web requests. So look at this very kind of straightforward version. You'll see that this has like this await syntax. Again, this is probably something you're not super familiar with. That's okay. Right? We kind of learn on the fly. The idea of await is it has to do with kind of how JavaScript works, and kind of it's a different paradigm of programming to some extent. So you're used probably to some programming language where it does like execute this thing, then execute this thing, then execute this thing. However, as I previously said, JavaScript is a very asynchronous language. It's kind of designed to deal with asynchronous things. Like right here, this is actually, maybe you don't realize it, but this is in and of itself an asynchronous thing. You might be used to instead writing, in Python or the equivalent in C or whatever. You might write like while true, time.sleep 1,000, right? And print hello, right? So every second we print hello, sleep 1,000. Or I guess we'd probably sleep 1 because that's actually in seconds. And every second it's going to print hello. Not the case so much here in JavaScript land. Or maybe it's similar-ish. The difference is what happens here with this time.sleep1. So time.sleep1 in the Python world or the C world, or maybe what you're more used to, the Java world, in a non-asynchronous world. In a synchronous world, this sleep takes place and it just blocks everything. And the whole application truly does just pause for a moment. But imagine we had like while true prints another time.sleep1. And you wanted these two while true things to run simultaneously. You want every second I want to see the word another appear, and every second I also want to see the word hello appear. If you're looking at this, you're probably thinking this hello block is never going to be reached. But what if there was some way to set it up that while we're sleeping in this chunk of code, I could be executing in a different chunk of code, because I don't really need to be doing anything during this second. We don't need to fully just block. We just need to make sure that we don't resume this loop for another second, right? So this is where the idea of asynchronous programming comes in, that we, rather than just sleep for a second, instead we await this. That's kind of, and turns out Python also supports asynchronous programming, but we're not going to get into that. You await this, which means this thing has the ability to wake back up in, let's say, a second when this thing is done processing, and then it can resume. But in the meantime, what await does is it says, okay, I'm done here, and this isn't exactly how you would write it. Somehow you would indicate that this is like one task and this is another task. You'd need some mechanism for indicating that so that these are actually differentiated in some way. And then this can await, and now you can kind of do both simultaneously. So that's kind of a high-level overview of asynchronous programming, and that's what's happening here. What the set timeout function does is it creates this task thing, and it submits this task onto the task queue, and it says, you know, in this case, it's kind of simple to think about asynchronous programming in that it's like we're very specifically statically saying I want to wait 1,000 milliseconds. But you might also want to do asynchronous programming where that asynchronousness is not just time, like just a static amount of time, but might be waiting on a networked request. So for example, you might await, as we see in this right here, we see this await fetch blah, 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 blah thing. This isn't like await a second, right? But we also don't know how long this might take. This web request could take a millisecond, and then in which case maybe we didn't even care about asynchronous, right? We could have just blocked waiting for this to come if we just had to wait a millisecond or something. Maybe that's acceptable. But you might also imagine that this web request might take like 10 seconds. Now, probably not. It looks like this resource movies.json probably is coming back in under a second or whatever. But the idea is like you don't really know how long this is going to take. And you might have background things. So for example, we've got this background task on this, if we go to here, we got this background task here that's counting up every second. If this blocked for a second here in and of itself, this thing would be off by 1, right? Every time you did that, this thing would have to stall out. So we await the response to come back. Hopefully that is clear. Kind of the idea. By awaiting, what we're saying is, okay, go do other work while you wait for this to actually come back. For example, updating this. So that's the idea of asynchronous programming. And this is maybe just kind of it's not that critical to, I guess, web security, but it is important to understand how the technologies you're using in any security thing, like how they work, because you know, as part of writing your exploit, you might need to await something or think about these ideas. That's why I'm explaining it. Okay. So let's go ahead and just show what the heck happens here then. We will, we'll just copy this code, right? And instead of this example.com, what we'll do is we'll fetch localhost date. And you'll see that my editor is complaining that like, oh, you're doing an await. Don't do an await. You have to be in an asynchronous function. Well, this is where you say, well, this is an asynchronous function. I'm not totally sure. I think JavaScript allows you to call an asynchronous function. I think we're going to find out. Python would not allow you to do this. For those wondering, you have to like basically say asynchronous pool person, like submit this into the worker thing, and that's how you like bootstrap your asynchronous stuff. I think JavaScript allows us to do this though. Let's see. Oh, probably, yeah, we did this. Okay, we gotta rerun it. Every time I modify this file, this thing automatically restarts itself, and so we got hit hard by that loop. Okay, so we counted to 1. Okay, something's not happy. Inspect, console. Oh, you'll see, look at this, the same origin policy. So if you watch my lecture videos, I talk about the same origin policy. And I'm happy to talk about that again, and maybe we will. This web request actually failed. It says the same origin policy disallows reading the remote resource. So if you paid attention to that same origin policy video, you might understand the issue of what happened here. The issue, for those that maybe didn't watch it, the issue is that my web application is running on localhost port 5000, and I'm trying to fetch a resource from localhost port 80. And these are two different origins, and you cannot read from a different origin. So that is not going to work. Really what we want is 5,000. Even if it could do that request, it would have failed, but the browser's not even going to attempt to do it because it's like, hey, I know what you're doing, and this is a violation of the same origin policy. Okay, so it looks like this succeeded. And I guess I'll say one other thing. Really, the way you would normally write this is just /date, because, you know, we don't even, if we migrated where this was hosted, right, maybe we put this on the internet and it has a real host, we don't want to have to like update our code, right? It's relative to our origin. We just really want to hit the /date resource. So that should work just fine. And maybe what we'll do is, I don't even know what the heck's coming back from this thing. Let's see if I put in response, what the heck is this response thing? Well, it's an object. Probably should read this thing. Response.json. How do I interact? Well, look at this. The docs say there is a response object that comes back. Well, what the heck is in this response object? The body, well, that's probably what we're going to want. Probably we're interested in the .body. You'll see there's also this like utility function. If I probably should zoom in a little bit. I gotta remember I'm on a large screen streaming here. You can also do .json, which this example does. And if I had to guess, that just looks at .body and does a JSON parse of it. That's my guess here. Let's see if we're correct. Response.body. Nope. And whenever you see returns a promise, that is like an asynchronous concept. It's basically like, I promise to give you the result. Just check back later, and you could like await that promise. Looks like we want .text. Returns a promise that resolves with a text representation of the body. So I'm not even totally convinced that this is going to be correct. We probably need to await response.text. Let's find out though. I'm guessing we're going to see some square brace. Yeah, see, we got a promise here. Now we could inline this, I believe, maybe. I don't know if that's actually true. We can in fact inline that. And the reason that this is also, so maybe you'll say const date equals await response.text. Maybe that would be a little more not so crazy by mixing everything just inlined. So you'll see that every second this is updating, right? We're doing another web request. If we go to the network tab, we'll see that every second we're doing it. And you'll see that this response only takes 7 milliseconds to come in. The reason you need to await this as well, if I had to guess, you might need to read the docs more. If I had to give my best guess, it's that this await finishes probably as soon as the headers come back from that HTTP response, but not the body. Because you could imagine there's HTTP things that will just keep streaming lots and lots of stuff to that body. Like imagine if you were going to fetch movie.mp4, right? Like this massive 2 GB file. Well, maybe the headers are done fetching here. So you can parse the response. You can understand what happened with this response, but the body is not done. So that's why we await. Of course, in our case, the body is very small. So like, it's like, why do I have to await this or whatever? Well, you do. Cool. All right, let's see if there's any questions. Oh boy, did I lose some of the chat? So sad when I lose part of the chat. Oh, the screen's not refreshing again? Well, gonna have to figure out what the heck's going on with that. Okay. Well, that's fixed, but that is very unfortunate. 11:40. It's been at least 4 minutes that it's been bad. Well, I am sorry about that. Maybe I should point out what I was talking about again. Gotta figure out why it's doing that. That's not cool. So what I was talking about here is we asynchronously can fetch this thing. So we wait for the headers to come in, and then we wait for the body to come in. So we fetch the date resource. We wait for the whole body to come in. We convert that to just text instead of like JSON or something like that, and then we can print this. So this is how we can make a web request. Okay. Dang. Very sad that this setup is not. It says encoding overloaded. Consider turning down settings. Can I don't know if I can turn it down though, like midstream. That is good to know that this is not the way. Is my laptop hot? Oh, it is a little toasty. That does line up. Huh. We have dropped 14 frames, but the bigger issue, I think I can see that it's stuttering. How do I fix this? Unfortunately, I don't think I'm going to fix it for this stream, but we will make sure we got it fixed for the next one. I think I got to downscale some things. I think I'm streaming at too high of quality. Yeah, I can see we got... Okay. Does anyone have questions about this module? So I just talked a bit about JavaScript. I should point out, I guess, something that probably will be... trying to just make sure how laggy this is. This is kind of laggy. What happens if I do this? Is this laggy? I think it's not. I don't know. Seems like randomly stuttery. Alright, we're gonna YOLO hit settings and see what happens. Output. Video. Yeah, video output is currently active. We'd have to stop the stream. I think this output scaled resolution is just like way too high. Or maybe it's the base canvas resolution. I don't know. Maybe I'll have to do some test streams. Okay. Sad. It's really laggy. Okay, well, we'll reboot the stream. That way, at least I'll know if it's fixed. All right, I will be right back. We'll see how this affects the YouTube video. All right, did we do it? Did we fix it? We thought the new setup would be cool. Not cool. This is, you know, I considered waiting for the new semester, like next semester or something. Okay, that looks correct. Audio. Okay. So yeah, consider waiting, and then I was like, you know what, let's do it. And then this is why we don't do that. Okay. So I downsampled everything to 1080. Hopefully everything's, or like, I don't even think I downsampled it. I think I just put it correctly at 1080. I don't know. I don't know the correct terminology here. I think that things should be able to handle this much better. One issue is that I'm like streaming on like a MacBook Air. It's probably a little bit crazy to do that, but it shouldn't be that bad. Okay. Is this working? All right, someone say something in chat. Are we working again? Hopefully we're working again. Maybe we're working again. We're dropping frames though. I think this is an internet issue though. Oh boy. Gotta investigate that as well. We got so many things to investigate. Is anyone in this Twitch chat? Nobody? Nobody's here. Everyone left. Do I have to refresh the chat? We might have to refresh the chat. I don't know. Oh. Visit page. What do you mean? Just test upload speed. Yeah, that's probably my issue. The heck happened here? Okay, there we go. Do I lose my chat link? Oh, no, there we go. All right. Yeah, I probably got to test my upload speed. But that, I think, is a separate issue than why we failed before. I think the CPU couldn't handle the stream before. Now, well, I guess probably drop frames are just from CPU. And maybe this thing, or this probably is CPU over here. The CPU slash FPS is a CPU thing. I'm guessing drop frame slash this network thing is a network thing. I'm guessing these two go together and these two go together. I don't know. How the heck do streams work? Been streaming since, I don't know, is it 2020? Or did I stream in 2019? I have no idea. Still don't know how this stuff works. We just hit stream, we hit go live, and we hope for the best. Okay, I think probably this stuff is smoother. So we'll try and, oh, look at this. We've got this going. So yeah, we can see, going back to this example here, every second, right, we start with this, I equals 0, asynchronous function count, we start off this count thing, and then every second we add counts as a function call back into the worker queue, like the asynchronous queue, basically, of things to process. And then the way this works, await is also like adding things into the queue. This basically says, hey, throw this in the queue, and like we're going to continue execution after this thing has finished its work. Same thing here. Every time you see await or async, there's like stuff's going into worker queue, and then more work happens while things are processing, etc., etc., etc. And then we do this. Okay. So this is a brief primer on asynchronous. And this is going to be important for you because, for example, I don't know which of these, but somewhere in here, possibly several of these things, you're going to be doing a cross-site scripting vulnerability, or especially a cross-site request forgery vulnerability. You're going to want to, at some point, inject JavaScript into something that some other user is going to automatically look at. So you'll see here, kind of spoiler alert, looking ahead at this challenge a bit. If we look at some of these things, so like for example, I think level 10 will probably have it. You'll see that level 10 has this ability, and okay, top tip, look at the source code of these levels. You'll see that in level 10 we have this like visit capability. So we'll go to /visit. And what happens is we boot up a browser, and a browser is going to visit something, and it's going to visit something logged in, and then it's going to go and go to whatever you told it to look at. And when it does that, there might be JavaScript running at whatever URL you tell it to go to. And suddenly this browser is going to be making additional web requests. Okay. There's a lot of ways to get a browser to make a web request. This is showing the JavaScript version of making a web request. You can also do like an HTML, cause HTML to force the browser to make a web request. For example, if I say image, why am I failing to think? Image source equals somewhere, right? I don't even know. Do we need closing image tag? How does HTML work? I don't know if image needs a closing tag. It probably doesn't, right? That would be weird, but maybe it does. Now we've got this little image here. And this little image, of course, doesn't look like a very nice image, but this little image caused the browser to make a web request to somewhere. And you know what? It said not found. There's lots of ways to make the browser make a web request. In some contexts, it might be very nice, though, to have the browser make web requests in this way, where you can actually start potentially reading the response. It depends, though. It all just depends. This is where stuff like same site policy comes into play. or same site within a cookie. So for example, let's see here. Or let's actually same. No, that's not what I'm thinking of. Here's what I'm thinking of. No, session. I don't remember how we do this. Is it like level 12? Level 11, level 10, level 9, level 8, level 13. This. Okay, so for example, level 13 does a fun little thing. So when we're making the browser make these web requests, there's a few things to think about here. So let's actually even make this crystal clear. This date request, it's, where the heck? Okay, let's clear out all these requests. Let's get a new one. This guy. Okay. This request here that the browser made, how do I, whatever, we'll just let it keep filling. One of these requests here that we made sent along a whole bunch of headers. One of the really interesting headers that you might think about would be the cookie header, right? The cookie header has to do with session stuff and allows the web application to know whether you're authenticated. We can see here that this web request, all these web requests here are not including a cookie header. There's no cookie header. Turns out though that you can tell it to include cookies. So send a request with credential. That's not quite right. Is it? Include credentials. Let's see here. Supplying request options. It is credentials, right? Yeah, credentials. This has to do with whether or not cookies will be sent. So you'll see that by default, where is it? These docs aren't as good as I'd like. This, okay, this is the part that we're interested in. Unless fetch is called with credentials option set to include, fetch won't send cookies in cross-origin requests, won't set any cookies sent back in cross-origin responses, and as of 2018 it changed to same origin. So okay, there's a few thoughts going on in my head. There's a chance that there just is no cookies. That might actually be why it's not sending cookies. Yeah, there's no cookies here. We'll see when we made a request to this root origin, there was no cookie. So what I'm saying is not actually true. Let's make it have a cookie. So we'll say session. We'll do this thing. This will convince it to make a session, and we'll say session who am I equals test. Okay, this is going to cause the browser to make to include a cookie, right? So now we get a set cookie. This session thing contains, basically it contains who am I test. We talked about this in the previous office hours. Let's see here. Now when we go to date, are we sending these cookies? We are including the cookie. Look at this. So we are in fact sending the cookie. So for example, we could do plus, or we could do, let's make sure, I think this should be, is this returning? I don't know whether it's returning it or not, but let's do plus session who am I, okay? So we're gonna get this. Okay, so we'll do this. Someone's not happy. This is bytes, decode it, make it a string. so we can see now, and we could even make it, separate. We can see here now it's including this cookie value. If instead we set credentials, so it said credentials had some options. Credentials omit. So if we go back to test.html and we say credentials equals omit, and we refresh and we look at this date, nope, looks like something crashed. Argument 2 can't be converted to a dictionary. Okay, I think we need to do actually this. It needs to be a dictionary. Oh, yeah, you'll see it's crashing. So we'll say on the server side, well, instead of just accessing who am I, we'll say default of missing. Okay. So if there's no cookie sent, it'll say missing. And you'll see it says missing because it's no longer sending the cookies. This right here just made it so it's not sending the cookies. Here's one thing I don't know. There's a lot of things I don't know. 127.0.0.1.5,000. Does it treat localhost in 127.0.0.1 as different origins? I don't know if it does. Let's find out. So I do this. Hello world. Yeah, look at this. The same origin policy disallows reading the remote resource. So I guess we're going to get hit by same origin policy before we can even deal with this. There's not even really a good fix to that. But we'll see that, we are hitting the same origin policy here. Okay. Yeah, so we can't even make this request because it is a different request. I wonder which part it doesn't like. Definitely doesn't like a get request. There's no way that if I set method to post it, it's going to allow it, right? That would be wild. Let's find out. Method post. Oops. Yeah, still not allowed. What is this cores parameter or mode parameter? Note that mode no cores only allows a limited set of headers in the request. Except language. Okay, what if we set mode to no cores? We're discovering things on the fly. Mode no cores. Yeah, you'll see that this request is actually allowed now. We're not getting hit by the same origin policy. That somewhere it's not thrilled about though. this is changing. See, the browser security is always changing. This is actually relevant for this. This is an issue for next semester. It looks like this thing is changing. Okay, so if we look at this network, right, the browser is now allowed to make this request. And it all has to do with defaults. The browser is allowed to make certain types of requests. With this fetch API, it is allowed to make the request as long as you specify a mode of no-cores. In the same way that an image, if we did this, it would also allow this request to be made. So if we do this, we'll see that the browser does not complain, right? It says that it fails, right? It says not found, but the request was made. We know the request was made. That's how it discovered that it's a 404 response. So the request is allowed to be made, and the browser is basically this giant gatekeeper deciding what requests is it going to allow someone to make. So if you have something like an image tag, generally whatever type of request is going to be made, it's like the browser is going to allow it. It just like makes sense, right? You might have an image somewhere, and in order to fetch the contents of that image, we got to be able to do this. I'm trying to think how to make this even, well, no, we'll just roll with that, right? So you can make a request. Of course, if it's not there, it fails, but it tried to make the request, got a 404. When we saw this thing with mode just defaults, whatever the heck the default is, we can see it starts blocking these requests. It just says, no, you're not allowed to make this request. The browser has decided, not the web server, the browser has decided that this cannot be made, and it's because this web request would violate the same origin policy. And what does the same origin policy talk about? Well, the same origin policy talks about what types of requests should be allowable. What kinds of requests can we make? And technically 127.0.0.1.5.000 and localhost 5,000 are considered different origins. Now we know that this is hitting the same web app, but that's not how an origin works. An origin just has to do with what the heck is this host name and this port and this protocol. Protocol, host name, port. This right here is the origin. And technically 127.0.0.1 and localhost are different host names. So if we instead switch back to localhost, right, which is what we're at in our browser, or actually let's not even do that. Let's keep it the same. Let's do that, and let's switch over to the different origin of visiting this. We will see that suddenly it is allowed. You're allowed to make this this web request. So this is the first question. The browser gatekeeps what kinds of requests can be made. Now, as we said before, though, if we turn on mode no cores, suddenly we're allowed to make more requests. So the browser is going to be more permissive to us. When we say mode no cores, suddenly the browser is like, okay, chill. So this is the same origin, so it's definitely going to allow it. But if we go back over to localhost 5,000, suddenly same origin policy is not blocking us. It's allowing us to make this request. Now you'll see that we get emptiness, right? There's nothing actually coming back. We don't get to read it. If we come over here, we still don't get to, oh, well, actually, it's not true. We do get to read it, right? So on 127.0.0.1.5.000, we get to read the response. Why? Because we're making a request in the same origin. And if it's the same origin, you're allowed to read the response. Same origin, allowed to read the response, 127.0.0.1, making a request to 127.0.0.1, same protocol, same port, we can read the request. We come over here to a different thing. No longer can you read the response. The response is unreadable now because the same origin policy says that if you, I think there's a good breakdown. It talks about all the sorts of things here. What has a good thing? why does it not? This. Yeah. So this is the same origin policy broken down. There are 3 types of requests, cross-origin requests. Okay. So same origin, we're pretty chilling. Cross-origin, okay, this is what it says. Cross-origin writes are typically allowed. So you're allowed to make the request, right? You're allowed to write out. So for example, a redirect. You could redirect the browser from one origin to a different origin, and that's chill. It's going to be allowed. Not all, right? It says some HTTP requests require pre-flight. We're not going to worry about that. But in general, you're allowed to like make the request. Cross-origin embedding is typically allowed. So for example, when I do that image tag, that is allowed. So you might be thinking like, how are we allowed to do an image tag? Because that sounds like a read, right? We just said writes are allowed, but an embed, that almost sounds like a read. Well, no, an embedding is considered different than a read. So you're allowed to embed something like an image. However, and then this is the final category, cross-origin reads are typically disallowed. And it says, but read access is often leaked by embedding, right? You can do weird things with embeddings to kind of sort of get some data. This is the issue, and this is why we can't read this response right here. So we don't get to read it. Yeah. So we'll see here, request, response. I wonder if in this part, yeah, no, we don't get to read it. Cool. Now this is a separate concern from this credentials thing. So whether or not you're allowed to make the request / read the response, that has to do with the same origin policy. Then there's the same site policy, which is a flag on a cookie, which has to do with whether or not cookies can be sent. So if I get rid of this, in fact, I'm going to change it to a different non-default. So credentials. There's kind of 3 values. The credentials can be include. They can be same origin, which is the default. By default, the cookies are sent on same origin, or they can be omitted. Let's go ahead and set it to include and see what happens. Okay. We're still making these requests, but these requests are being made, blah, 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 blah. But if we come over here, I'm slightly skeptical about this. Let's see here. This right here, we'll see now it's including the cookie. So the cookie is being sent. Yeah. I don't know. Is there any questions about this? There's like a lot going on. You kind of have to experiment with some of this stuff. Yeah. All right, we're gonna leave it at that. I'm gonna wrap up this office hours. As always, if there are additional questions, feel free to ask. Sorry, this stream was a little bit chaotic as we're testing the new setup. I'll try and make sure it's better for the next one. Anyways, thank you all for joining, and I will see you in the next office hours. Feel free to ask questions on the Discord, and good luck on this assignment. Yeah, the stream should be saved. At a minimum, it'll be available on Twitch for the next like 14 days. Hopefully both will make it to YouTube. Okay, goodbye.